Hello, Mr. Eric. How are you today?
Good.
Okay, so today we talk about a simple function in Python, which is called accumulate.
It's spider.
Accumulate.
Here.
What does it mean? Accumulate. Accumulate. How do you spell it? How accumulate? What does it mean? Eric? Accumulate. What does it mean? Accumulate. Accumulation. Accumulate. So Eric, look. It means to accumulate, to put the things together. Yeah. Look, Eric. 1, 2, 3, 4, 5. At least, right?
6, 7, 8, 9,
Yeah.
10.
Alright. So when you accumulate this array, what happens? Then you tell me what does it do? Yeah. 1, 3, 6, 10, 15. Okay. So when you accumulate it, you become this. What does it mean?
That.
It's a generator. It's actually a generator of this.
Wait, I think I.
Yeah.
Actually, no. I thought like.
What?
Add 0, add 1, add 2. No.
Quite close, yes. What does it mean?
0, 1, 3.
Why this is 0? Sorry?
Wait, what?
What's 0 coming from?
I was like doing like 1
Yeah?
plus 0. Then I was like 2
1.
plus 1.
Yeah?
And I was like, yeah, you know.
Yeah, and how about this here? What's a 6? What's a 6?
6 is double.
Look carefully, what's 10? And what's 15? Come on, what's it compared to the previous one? Come on,
3,
okay.
6, 9. No.
Come on, you're quite close, come on. What's between these two? What's between these two? What's between these two? What's between these two?
2, 3, 4, 5.
Yeah, and why is that?
Well,
Why is that? Why is that? Accumulate, you don't understand this word? Accumulate. Let's look up in a dictionary, what does it mean? If you know this word, you probably understand what it means, yeah?
maybe I do.
Accumulate. Yeah, accumulate. What is it? What is it? Gather together. Yeah, investigation. Gather together. Acquire an increasing number, a quantity of. What is it? Does that ring a bell? Does that ring a bell? Okay. Look.
Yeah.
What's the sum up to this point?
1,
What's the sum up to this point?
3,
What's the sum up to this point?
6,
Do I need to continue?
9.
So what's the accumulate? Tell me, explain to me.
So 1, 2,
1 what? 2 what? 2
1. Okay, so 1, 3, 6, 10, 15.
Yeah, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 4, yeah? This is to accumulate, yeah? Yeah?
Mm.
Because we want to know up to this point the sum, how many, the sum of these point and until this point, right? Does it make sense?
Yeah.
So this function, look, is from it to us. So you want to use it, you can use this from it to us, yeah. Iterate to us, import this, iterate to us. Yeah, from iterate. Is it from iterate or it function? Actually, I'm not quite sure, but let me just double check. From iter to us. Yeah, Listen. From it to us. Iteration to us. Import, accumulate. Yeah? Import, accumulate. We want to use this function, accumulate. Does this one it to? Remember, we have used this from it to import what? Remember? Cache. Yeah, is it cache? ARU cache. Remember, we're using this. Yeah. So this tool provides many functions. Yeah. So this I think it's from here. So look, if array equals
array in a circle.
Okay, so like that, and then look, let us say A equals equals what? Equals accumulate.
Dot code.
Accumulate and AR. Yeah, and then you want to print it. You can say print. Print, but you need to turn this into a list because this is a iterator, generator. Remember? So this generator, what does it give you? It gives you one element at a time, right? So you can for I in accumulate do this, then you print 1, 3, 4, 10, right? So print list A, then it will give me 1, 3, 6, 10, right? Yeah? Alright? How can we implement this function? Accumulate.
Define.
Yeah, let's say we don't want to use we want to reinvent the wheel, okay? Define, let's just call accumulate, yeah? Accumulate, or accumulate, okay? And then let's say A is the number the array, right? Alright, look. So look. What? So how can we do this? We can change the numbers in the we can change this array if you want. Eh? We can change it. We don't need to create a copy. Look, we can change it. Look, for I in range what? Let's say 1 to length. We start from the first one, because the first we start from the second one. The first element does not change, right? Look, 1, 2, 3, 4. So how can we change this? The first one doesn't change, right? The second one is equals to its number plus the previous one is 3, right? And what's the next? Is 3 plus its previous one, 3, which is 6. And what's next? Is 4 plus the previous one, yeah? Does it make sense? Yeah?
Yeah.
Okay, so for length, the A column, look what? AI plus equal what? Can you tell me? Huh? Plus equal what? AI plus equal what? What did I just say?
The next.
So what? We start from the second number. So every time this number, we want to update it with the sum plus
The next one.
the previous one. Come on, what is the next one? The previous
0.
what? What's the previous one?
-1.
I minus 1. And then return A, yeah?
Yeah.
Because when you return A, that's a list, that's not generator. So how can we make it a generator?
Generator.
Yeah, remember we seen this keyword before, yeah?
Oh,
Yeah,
yeah.
from A. That's it. Because we want to add one element at a time. We don't want to add the same thing. So from A means that we want to add one element at a time. So you will give me exactly. So this is exactly the same function as from iterators. Import, accumulate. It's the same thing. Yeah, we are reinvent the wheel. Yeah, reinvent the wheel. What does it mean? So it means we already have the wheel, but we want to reinvent it. We want to
make it again.
make it again. Yeah. So why we're making it? I just want to demonstrate what's behind it, right? The accumulate function. That's what it is. Yeah. Yeah. All right.
Yeah.
We are modifying this. If we want to make a copy, we can say like a new, right? New array, right? Equals deep copy. Copy.deepcopy, right? A. Right, we can copy a 1 and then we can do this. And then we can do this n equals. It's the same thing, yeah? Does it make sense? Yeah? Or we don't need we can do this, Eric. Create a new array. But instead we can do this. N dot append, because n the first element, it needs to contain the first element, right? And then the second element will be n append what? AI is current element, right? Plus n minus 1, right? Alright? Does it make sense? So it's the same thing. So every time you append the current element and the previous element, previous element of n. Look, Eric. The A is what? 1, 2, 3, 4, right? And n at the beginning I set it to the first element, which is 1, okay? and then do this. I will be 2 here, right? N dot append AI 2 plus 1, right? The last element of n is 3, so I put it 3 here. Okay, so next one, 3, I equals 3, right? AI is 3. 3 plus the last element of n is 3, so 6. Alright, and the next one, 4 plus the last element of n is 6, so that's 10, right? Does it make sense? Yeah, this is the making a copy, but we don't need to, as I said, we can just directly modifying, yeah? AI plus equal AI minus 1. Got it?
Yeah.
So basically, when you add in this AI minus 1, it's already the sum of the previous I minus 1 items, right? Yeah? So we can reuse this. Does it make sense, Eric? Look, here, I start with here, yeah? Okay, so 2 plus the previous item is 1, right? Yeah?
Mm.
I erase it, 3. So now the next, 3 plus the previous item.
6.
Yeah. Does it make sense? And then go to here, 4 plus the previous item.
10.
Does it make sense, Eric?
Yeah.
Yeah. What's the time complexity?
N.
Yeah. What's the space complexity?
N.
If we are modifying this, what's the space complexity?
N.
We are modifying it. We are not using any additional array.
1.
Huh? We are not using any other things. This is input. What's the time?
OA.
Why is that? We are not using any space.
O.
OR. What's the not using?
1.
O1,
I
constant.
just said that.
You say OA. What's OA?
I said that before.
Okay, you didn't say it loud. You need to be confident, okay? If we are making a copy, that's ON, right? Yeah, but we're not. Then that's okay. Like yield is, what's yield? What's yield? Giving you one element at a time, yeah. So you can use it it's a generator, right? So you can use it in a for loop. You can say for I in accumulate, and then it will give you one element. Why is that? Look, because if A contains a million, if A contains a million elements, then I don't want to return a million at the same time, right? Maybe I just want to use one at a time, right? So give me one, right?
Mm.
Yeah. If you give me a million elements, I may not need it. Just give me one, right? For example, like we can have this may not be a very good example because we are calculating the entire array at the same time, right? At once. So look, do you still remember the prime numbers? How many prime numbers are there? How many prime numbers?
Up to what?
No, I mean, in reactive, how many prime numbers are there? There's no limit. How many?
About.
How many prime numbers?
About quite a lot.
I know, quite a lot is what? Is it limited or unlimited? Is it finite or infinite? Is it finite or infinite or unlimited? Which one? Unlimited.
I didn't know what any of those.
You don't know this one?
I know, I think I
Oh,
know.
count this. Count this. Do you understand this word? Count this.
I'll go for.
Which one? Count this. Count this. What do you mean?
You can't count it.
You can't count because there are as many as you want, right? Yeah?
Mm.
So which one? Pick one.
I'll go for.
What?
What's finite?
Finite is that maybe 10, 20 you can count it. It's opposite of counted. Infinity is. Remember the infinity. Yeah? Yeah?
Yeah.
That's the positive infinity minus infinity, right? So which one? Okay, which one? It's not fish. Come on. Give me the answer, please. How many prime numbers?
I'll go for unlimited.
Unlimited, count this, infinite. All these three are the same thing. It's okay, right? Yeah, it's because it's as many as you want. Why are we talking about that? Look, Eric. let's say, okay, let's say the if, yeah, if, how can we prove it's unlimited? It's very hard, yeah, but I show you. Look, if we,
Because we say so.
if we assume the prime numbers are limited, okay, yeah?
Yeah.
Let's say if it's P1, P2 until Pn, right? Yeah? If it's finite, it's finite, right? It's n, if there are only n prime numbers, yeah? Yeah?
Yeah.
How about if I times it together? Yeah, times it together, right? That would be not a prime number, right? Because you can find this, right? Yeah? Alright? How about I plus 1? So if I plus 1, that becomes a prime number, right? Because it cannot be divided by any of these prime numbers, right? You cannot find any number. So what does it mean? I find another one prime number which is not P1 to Pn. Yeah? Alright? Our assumption is that there are only Pn, there are only n prime numbers. But if I multiply them together and plus 1, I found a new prime number. So what does it tell us? Our assumption is wrong, right? So what's our assumption? Our assumption is there are only n prime numbers. So it's wrong. What does it mean? The prime numbers are countless. Alright?
Yeah.
Is it elegant? Is it beautiful proof?
Maybe it is.
Yeah? This is the opposite, yeah? You assume something is right, and then you prove, and then you prove. You come back to your proof, and then you say, oh, my assumption is wrong. Right? So the opposite of the assumption is that the number of prime numbers are unlimited. Does it make sense? Yeah? Okay, so why we talk about prime numbers? I want to talk about, because it's unlimited. So if I have a function like define get next prime. Yeah?
What does that mean?
Get next prime. Give me a next prime number. So if it's 2, the next one will be 3, 5, right? Because it's unlimited. The list is always unlimited. You can't return a list of unlimited, right? Does it make sense?
So like if you go for 2 and 2 is a prime number, do you need to give a prime number?
So yeah, this prime. So I want to use this function, yeah. Get next prime number. I want to do this. I want to do this. Y. Let's say maybe I just do this. Print. Yeah. Get next prime number. Get next prime number. Okay, that's it. And then I will have a loop, right? For I in range maybe 10. I want to print the first 10 prime numbers, right? Do this, right? You see? So this is the, you will give me a number every time, right? Does it make sense? You will give me a number every time. Because the list, a list, maybe I can write it this way. Maybe it's better. It's clear. For I in what? In get prime numbers, and then I just print. Okay, print I, right?
Yes.
Yeah. So look, this get prime numbers is unlimited. There are unlimited number of prime numbers. But every time I want to, I will return a I will print it. So here, no, nothing here. So here, I was just saying I want to yield a prime number, right? Yeah. Yield a prime number, right? I want to yield a prime number instead of generating a list of the, because in this case it will not be very good to generate a list of prime numbers, right? Because it's unlimited. Does it make sense?
Yeah.
But I know the next prime number. Yeah? I don't know how many more numbers I need to give you, because it's unlimited. But I know the next one. Does it make sense? Yeah? So that's why the yield from. Okay? Got it?
Yeah.
Okay, that's it for today. We talk a little bit more. Okay, that's it. Say bye bye to people.